How's it going, ladies and gentlemen? My name is Austin Farrar. We're here with another calculus problem in Challenge 2016. Alright, so tonight what we have for you guys is we have an integration problem from 0 to infinity, and the question, just read that off to you guys real fast. So from 0 to infinity, 2e to the negative theta, sine theta d theta. Alright, so the first thing I think when I see this is that, alright, I have 0 theta, which means this is an improper integral. Again, this is an improper integral. Meaning at some point we're going to have to take this data into account and change it to something else. Alright, I'll get this that later in the video. So as you can see at the top, we have the original function, and we have u equals e to negative theta, du is negative e to theta. Again, I'm using integration by parts here. And so, let me back up a second. I'm using integration by parts, and so you separate everything into u, du, and dv and v. So first, I get my u by looking at the function that's easiest to differentiate. Okay? So I have my e to negative theta right here. It's pretty simple to differentiate, right? So change that to e to negative theta to negative e to theta. Alright? That's just the derivative of u. Okay? Move over to this side. We have our dv, and we're looking for the function that's the easiest to integrate in this sense. So dv equals sine theta. The integral of that is just negative cosine theta. Again, you can check yourself by going, okay, what's the derivative of negative cosine theta? And it should get you this function. Double check yourself. Okay? Now that we have uv and v and du, what we do with that now is use this equation for integration by parts. Okay? Which is the integral equals uv minus the integral of v du. So all I did here, guys, is I pulled up my 2 and I plugged in what I had here. So I have my uv right here, so u times v right here, minus the integral, keeping the same indices right here, of v du. Okay? V du right there. Perfect. So once we get that all squared away, a little simplification here. Okay, and we end up getting this function again. And so what we do now is we do integration by parts a second time. So again, I choose the function I choose function that's easiest to differentiate, which in this case is my e to negative theta. Do the derivative of that again. And then I have the function that's easiest to integrate in this sense, which is dv. Take the integral of that and get this. Then plug all that again back using the same formula into this part right here. Okay? So once I do that, I get this again. And at this point, I'm going to bring my 2 back in so easy for you guys to see this next really interesting math thing that happens. See the math thing that happens. I have my retainer, so I got to work on that. But what happens here is, if you notice, this boxed off piece of the equation we got when we plugged in this right here is the exact same thing as what we got at the very beginning. So that tells you, okay, the next part means you have to take what you have here and divide it by 2 since we have 2 of the same thing. So take what's left here, divide it by 2, and now you can see I'm dealing with the improper integral portion of this. What I'm doing here is I'm saying limit x approaches infinity, and I change my thetas to x's just to make it a little simpler to see. Okay, change my thetas to x's here, and so I'm saying limit x approaches infinity, and x in this case, there should be an x right here. I'm changing the top part of the integrand, again, which is this infinity sign up here. Let's make this an indefinite integral. So I'm changing that to an x. And now what you have to do is regular integration. Okay? So what you do next is you plug x in here, plug 0 in here, and once you get that, you realize that as x approaches infinity, for this function, when you plug in x and you subtract that from plugging in 0, what you get is 1. Okay? Now you can do the math yourself. I don't have a whole lot of time in this video to do that for you, but take my word for it, okay? You can look up on Khan Academy or another amazing math website. Thank you for watching. Have a great night. Please leave any questions, comments, or concerns in the description below. Don't forget to be awesome. Austin Farrar out.